Tick-tock, people. All right. I would like you guys to try, let's say, first off, let's try D, 1D. Okay, this is in your digital workbook if you're having trouble reading it up here, but okay, 1D I would like you guys to try right now. It's pretty straightforward. Kind of just as a way to get our feet back on this. Doesn't require any components, okay, just perpendicular. Well, let's give that one a quick try here. Okay, so for this first one, we just have two perpendicular vectors, okay, but we still have to make sure we draw it tail to head. So we're going to go 8 meters west, okay, and then we're going to go 5 meters north. Okay, which means our resultant will go from our initial position to our final position, like so, okay, have an angle here, and this will be our overall displacement. Okay, our magnitude of our displacement can be calculated by simply going 8 squared plus 25 squared, or sorry, plus 5 squared, which is 25. Okay. So, and then our theta can be calculated by simply going opposite over adjacent. Okay, so 10 to the minus 1 of 5 over 8. Okay, which should give us our 9.4 meters, okay, at 32 degrees north of west. If you drew the triangle the other way, okay, so if you drew it like this instead, then you're going to get that complementary angle of 58 degrees west of north. Okay, questions on that first one? So that's actually like the vector addition stuff we were doing 2 days ago. Okay. What I would like you to try next is one where you are finding the x and y components. So I would like you to do C here, please. Okay, so draw the vector, then find its x and y components. Okay, so for this vector here, we've got a 20-meter long vector, 52 degrees west of north. What's my reference direction? North, yeah, okay. So I'm going to draw a line north, and then the question says go west of that 52 degrees. It's not a very good triangle, but you get the idea. Okay, 20 meters long, 52 degrees. This would be x, and this would be y, okay, or the west and north components. Okay, so if I want to find the x component, what trig function am I going to use? Which side is it? Opposite. What trig function do I use if I'm using opposite and hypotenuse? Side. Okay, so x is going to be the sine of 52 degrees, okay, times the hypotenuse, which is 20, okay, and that should give us 16 meters west. Okay, so in other words, that's what x is 16 meters west. All right, if I want to find y, y is the adjacent side, cos 52 times 20. And if I punch that in my calculator, I should get 12 meters north on that. Okay, ringing a bell. How to find those vector components. Okay. I want you guys to try C. Okay, 8 meters east and 6 meters at 35 degrees north of east. This one's going to require a vector diagram. Finding vector components, putting those components together, Pythagorean theorem, finding the angle, okay? All that stuff we worked on yesterday, but that is an exam level question. Okay? And it's like the question you're going to have on your quiz tomorrow. Okay, well, let's have a look at the diagram. Just as a refresher, a compass goes in this order. Never eat shredded wheat. Okay, clockwise, around that way. Okay, so our diagram for question C should go 8.0 meters east. And then we should have 6 meters at 35 degrees north of east. So my reference direction is east. I'm going to go 35 degrees north of that. .0 meters, 35 degrees, x, y. Okay, which means my resultant should go like so. Okay, I can draw my resultant one of two ways. I could draw it right over top of everything I just drew, which I find busy and kind of hard to look at. Okay, or you could draw it up here, where your triangle is kind of outside of your other drawings and sometimes it's a little easier to look at. Okay, that would mean this is theta, this is d, this is x, and this is y. Okay, that's what your diagram should look like. All right, if it doesn't, adjust. Then you can move on to finding your x's and y's. Okay, let's have a look at the next couple of steps here, guys. Okay, next step that we need to look at is calculating our x's and y's. All right, for our first vector, it goes straight east, so it doesn't have a y component because it's not angled. Okay, it just travels along the x-axis. Right, so its x component is going to be 8.0 meters east, okay, and its y component is going to be 0 meters because it doesn't go north or south. Okay, everyone okay with that idea? Okay, I didn't have to do any trig for my purple 8-meter long vector. Okay. Now, for the black vector, okay, the 6-meter long vector, that does have a bit to the east and a bit to the north that I do have to figure out. The x component is adjacent to the 35-degree angle, so I'll calculate that by going the cos of 35 times 6. Okay, so I get 4.91 meters east. Okay, and then to get the y component, it's the opposite side. So sine of 35 times 6. Okay, so we got 3.44 meters north. Okay. So I want to figure out how big D is and what direction D is pointing. Do I have enough information now to fill in two sides of its triangle? I do. Okay. Is black Y the only time where I went north? Okay. So what's the relationship between black Y and red Y? They're the same. Yeah. Okay, they have to be. They're two sides of a rectangle. All right, so that means that red y, okay, we calculate, come on, red. Okay, red y is simply equal to 3.44 meters north because that's the only time I went north in the entire question. All right, and then how would I get red x? Yeah, okay. I mean, in the 8, we went east only, and then in the 6-meter vector, we went 4.91 meters east as well. So I would add those two together, and that would give me red x. I mean, if I look at it, again, this is one big rectangle, so this side, the bottom, has to be equal to the top. Right? So we would be looking at, with all of our decimals, obviously. 8 plus that number. Okay, so we'll be looking at 12.91 meters. Okay. Okay, so now I've got the two sides of my displacements or my resultants triangle. Can I use them to get D? Using Pythagorean theorem. Okay, so if I use Pythagorean theorem here, okay, big D is going to equal the square root of 3.44 squared plus 12.91 squared, obviously with all the decimals in place. All right, so we get that our overall displacement to two significant digits is going to be 13 meters. All right, and now I need to get theta. Now, depending on how you drew this, you may have drawn your triangle this way, okay, and if you did, that's fine. You're going to get the complementary angle to what I get, okay, but for me, the triangle is drawn this way. X is opposite, Y is adjacent, okay, so theta will be tan to the minus 1 of 12.91 over 3.44. Okay, so I get 75 degrees. I only have two significant digits. And for me, that is going to be east of north. Okay, so our final answer is going to be 13 meters at 75 degrees. East of north. And then if you had the complementary angle, then you got 15 degrees north of east. I think I'm at 14.7, but there's only two sig digs there. Okay, is that ringing a bell from yesterday? Okay. I've already put your quiz together. The question you will have will look like that. Okay, it'll have one line that is either along the x or y axis and one line that is angled. Similarly, I will have a question like that on your unit exam as well. Okay, that's an exam level question. Okay. Well, let's have you try one that's got two angled vectors. Kelsey, question? Yes. Okay, try E. All right, I'll give you a few minutes and then I'll put the diagram up so you can check if your diagram's right before you get into the math. The purpose of E is to illustrate the importance of scale in your diagram. I mean, you don't have to measure it, but you better be careful about it. Okay? Okay, so for E, okay, which is the one we're working on here, our first vector is 5 meters at 26 degrees south of east. All right, so my reference direction is east. Okay, so I'm going to do that, and I'm going to go 26 degrees south of that for 5 meters. Okay, so that's my first vector. My second vector is 7 meters, 58 degrees west of north. Okay, everybody with me there? Okay, does that go almost right back along the first vector? Almost, okay, not quite, right, but almost. Right, so it is west of north, so I need to draw a vector here that is due north. Okay, and what I do if I've got one that I know is going to do a lot of backtracking, okay, what I'll kind of do is calculate maybe what the two that are backtracking each other are before I start, so that I have an idea of where to put that other vector. Okay, so at 58 degrees, so I'm going to go sine of 58, and it's times 7. Okay, so it's 5.93. Okay, and this x here is 4.49. All right, so here's what that tells me. My 7 meter vector needs to go like this. Okay, how important is scale on that one? Very important. When the first time I did this one, I ended my thing like over here, right? Which is totally in the wrong place. Then I did all my math, and my math told me I was supposed to be over here because my final vector was west of north. I'm like, oh crap. And I almost did the thing I told you that everybody does. I looked at my math and went, my math must be wrong. Because my picture couldn't possibly be wrong. But my picture was totally wrong. I hadn't made my angle big enough. Okay? And probably the vector long enough either. Okay? In terms of scale, this is important. My 7-meter vector is longer than my 5-meter vector. And that's why I end up on the other side of my starting point. Okay? Really, really important, okay, to make sure we're doing those things. So here's x and y for that vector, and that is going to mean that our resultant is this short little line right here. And that's my resultant's triangle. And this is about as tricky as a 2-vector question will get, okay, where you have a complex backtracking diagram.
Would we ever have this on an exam?
Nope. But you could get it on an assignment, which would still be worth marks. Yeah. Okay, I'll give you a few more minutes to get some of the math done here. Okay, let's have a look at what the rest that we have to do here. So we'll start out with our red vector because that was our first vector. All right, I've got to get its x and y components. All right, its x component is adjacent to the 26-degree angle. All right, so I'll use cos of 26 times 5, the hypotenuse, in order to get that number. So cos of 26 times 5 is going to give me 4.49 meters, and that is east. All right, and then y is going to be the opposite side, so that'll be sine of 26, okay, times 5, which is 2.19. Sorry, sine of 26 times 5 is 2.19 meters, and that'll be south. Okay, everybody all right with that? Then we've got to do the same thing for the black triangle. Okay, and for our black triangle, black x is the opposite side this time. All right, because the angle is down here, and it is 58 degrees. Okay, so black x is going to be the sine of 58 degrees times, sorry, how long was x? It was supposed to be 7 meters long. Okay, times 7. All right, so that is 5.93 or 5.94 meters, and that is west. Okay, so I've done that right. I did go further west than I went east. Okay, so I've got the right numbers in there. And then I've got to calculate y. Y is adjacent to the 58-degree angle, so that'll be the cos of 58 times 7. Okay, so we're looking at 3.71 meters north. So everything in this question is opposite. Okay, the first vector goes south and east, the second vector goes north and west. So what am I doing with everything when I find my resultant? I'm subtracting it all, right? That's how I'm going to get such a small resultant triangle here. Okay, everyone with me so far? Questions so far? Okay, just in case you're wondering, like, where would I get marks on a test for all this stuff? You get 1 mark for the diagram, 1, 1, 1, 1, okay, for all of those, right? And you would get a mark each for getting the green, or the resultants x and y, in this case the green ones, right? So my resultants x is going to be 5.94 meters west minus 4.49 meters east. All right, but I'm actually going to use all the decimals. looking at 1.44 meters west. Okay, so this one here is 1.44 meters west. All right, and then I've got to do the same thing with green Y. Okay, one of them goes south, the other goes north, but the north is bigger. So 3.71 minus 2.19. Again, with all the decimals. Okay, so 3.71 minus 2.19. All right, so we're looking at 1.52 for that side. Meters north, and so 1.52. All right, can I get my displacement now? Yep. Okay, so now I do what step? I know the two sides of the triangle, so I do. Now I do Pythagorean theorem. Okay, so we're going to go with big D equaling 1.44 squared plus 1.52 squared. Obviously, again, with all the decimals in place. All right, so my resultant is 2.1, because I think I only have two significant digits here, so 2.1 meters. Okay, and then I've got to find theta. The way I drew this triangle, y is opposite and x is adjacent. Okay, so theta is going to be tan to the minus 1 of 1.52 over 1.44. All right, so 46.4, I have the wrong answer on there. So it should be 46, not 47 degrees. Okay, 46 degrees, and for me, that is north of west. Okay, if you got 14 west of north, that's also fine. Yeah. All right, how are we feeling about that? Is it still a lot of work? It is, okay? So just so you know, the rest of the marks, 1 mark for that, 1 mark for that, 1 mark for Pythagoras, 1 mark for that, and 1 for that. I think that comes to a grand total of 10. Okay, so that'd be a 10-mark question. The one like would be on your exam would be a 8-mark question, maybe 6. Actually, sorry. Yeah, 8-mark question. All right. Okay, I'm going to give you a 5-minute break here, and then I'm going to put a different one on the board for you to try. Because the only way we get better at this is to do it. This is one of those practice kind of things. Okay, guys. I'd like you to try this one. Okay. So you got a combine harvesting a field. First it moves 950 meters at 30 degrees north of west. Okay, and then it turns and travels 385 meters at 40, that's supposed to be 45 degrees. I don't know what happened with that. So 45 degrees, I'm just gonna do this. Okay, south of east, and then the whole trip takes 540 seconds. What's the average velocity of the combine? So you got to do the whole vector thing, the whole thing we've been doing, and then there's one little tiny quick step at the very end of that. Okay? Give you a few minutes to get the diagram drawn, and then I'll draw it up there so you can compare. All right? Is scale going to be fairly important on this one as well? I mean, it's important on all of them, but on this one, because it backtracks, first it's north of west and then it's south of east, I'd say scale is going to be important here. Okay guys, I'm just gonna get the diagram drawn up here so you can compare it to yours. Okay, so our first vector is 950 meters, 30 degrees north of west. Okay, so that means my reference direction is west. Okay, and that is the longer of my two lines. Okay, and I'm only going 30 degrees north of that, so. Oh, that's terrible. Okay, fine. Okay, so this is going to be 30 degrees. Okay, this is going to be 950 meters. This will be y, and this will be x. All right. Now, our next line goes from here, but it is south of east, 45 degrees. All right. Now, if I start drawing this direction here, okay, this angle here would also be 30 degrees. Would you agree? Like law of similar triangles, if that's 30, this is 30, right? Because this would be 60 here. So my 45 degree angle should go a little bit below this line. Yes? Okay. And how long should it be compared to the green line? A hell of a lot shorter. Okay? It's like way less than half as long, right? One's 950, the other is 385. Right? I've seen just walking around a lot of diagrams where the 385 meter line is like way over here. Okay? Scale is important. Okay? So 45 degree angle would split that right about in half. So something like that. That angle is 45 degrees. And there's my triangle. I don't need that much line over there. This would be x, this would be y, and this would be 385 meters. That's going to put my resultant like that. Okay, now, how busy is that diagram? Is it almost like confusing, hard to look at? Right. If you're finding, like for me, I still want it busy. I still want to be able to see the whole big picture. But if you're finding that that diagram is kind of a lot, okay, a lot to look at, you can do what we call the separate triangle method. Okay, and it's exactly like it sounds. I just don't connect tail to head those vectors. I just draw their diagrams separately, and then I put all the x's and y's together at the end to make the final picture. The drawback of that method is I don't see what my resultant looks like until after I've done all my calculating. The plus side, I don't have to look at a busy diagram. You have to decide what's going to work better for you. Okay? If I'm drawing this as a separate triangle diagram, this is what I end up with. Okay, so I don't put them together. I just draw them separately. Is all the math going to be the same? Absolutely. I don't see this blue triangle until after I calculate all the x's and y's, and then I assemble it after. Totally up to you. Mathematically, absolutely the same process, but if you're finding the big diagram to be a lot to look at all at once, try the separate triangle method and build that final triangle after. Totally up to you which one is going to work better. Okay, I'll give you a little bit of time to get ahead of me again. Okay, let's look at the rest of this here. So from this point forward, doesn't matter whether you're using the separate triangle method or the combined method, okay, the math is the same. I still have to find all the x's and all the y's. All right, so for finding green x, I'm going to go and take the cos of 30, okay, and multiply that by 950, and that's going to give me 822.72. Whoops. 822.72 meters west. Okay, so I know that this line here is 822.72 meters. All right, then I calculate y. Y is the sine of 30 times 950, which is half of 950, or 475 meters north. Okay, and now I want to do the red triangle. Now the red triangle is easy because it's a 45-degree angle and both sides will be the same, right? They'll be equal because it's a 45-degree triangle. All right, so I only have to do this calculation once. Cos of 45 times 385 gives me 272.2. meters east and 272.2 meters south. Okay, so if I'm doing the main triangle or the combined triangle method here, then I already know what D looks like. If I'm doing the separate triangle method, now is when I build that separate triangle, okay, or the resultant triangle. So I know, okay, that I've got to calculate what blue x is, which I also have to do here. I just know what it looks like. All right, so blue x is going to be 822.72 minus, okay, the one that goes back, which is 272. All right, so 822, okay, minus that one. All right, it's going to leave me with 550.49. meters west. All right, so what I do then is I go, all right, now I know what that triangle should look like. 550 meters west. Okay, so I've got one side of that triangle now. Okay, I'm building it blind, okay, unlike in this method where I can just go 550 meters. Okay, that's great, I can do that. Okay, but on here I've got to build it blind. All right, next thing I got to calculate is the y. All right, so I'm going to take my 475 and subtract my 272. So 475 minus that 272. All right, it's going to leave me with 202.76. 475 minus 272. Okay, it's going to leave me with, sorry, it was 202. Okay, so then I go up like this. Okay, and I say that's 202.72, and I draw my hypotenuse. Okay, does that separate triangle that I built totally blind end up looking just like the one I built within my diagram? Okay, because it's the same math. It's just whichever one of those methods is more visually appealing to you, go ahead and use. Okay, I have zero preference in terms of which method you use. I have a preference for which method I use, okay? But if you're better with the separate triangles, absolutely go right ahead. All right, so now that we've got that triangle built, now we can calculate what D is. That's B of D, okay? By doing Pythagorean theorem. So we'll take our 550 squared, okay, plus our 202 squared, and our resultant is 586.6 meters. And then we'll calculate theta using tan, okay, because y is the opposite side, the way I drew that. So second tan of the 202 divided by the 550. All right, gives me 20.2 degrees. If I go back up to my numbers here, oh, actually I'm not done yet. Okay, so I've got now my displacement, 586.6 meters, 20.2 degrees, north of west. What's my last step? I'm supposed to find the velocity of the combine knowing that this whole thing takes 540 seconds. V equals D over T. You just did all that work to get D. Okay, so you could do V equals D over T. All right, so final calculation, V equals D over t, take our 586 or whatever it ended up being there, and divide it by 540 meters per second. Okay, so this number right here, divided by 540, is going to give us a velocity of two significant digits, because that 30 degrees only has two, 1.1 meters per second at 20 degrees north of west, or at 70 degrees west of north, depending on how that final triangle turned out for you. Okay, you have a quiz tomorrow. As I said, it's going to be one of those ones where one line is straight along an axis and the other is angled. Okay, your practice quiz has one like that and one like this. Okay, totally up to you whether you want to try both, but know that it's only going to be on the first question type, because I can't give you two, or we'll be doing it all class. Okay, so one question only. And then, stop for a sec, guys. And then we're going to talk about your labs. Okay, yours are marked. Back to you already, you can check your mark. Okay, but we'll go over those. I'll give you the feedback, tell you, kind of just show what I would have wanted in each spot, so you have an idea of why you got the mark you did. Okay, and then we'll move on from there.